All right, so we are now, day 3 notes? Woo! Now we're going to talk about increasing and decreasing, which, as you can see from my football fields, are still in interval notation. So I'll kind of briefly go over that. If you weren't here yesterday, you'll want to watch yesterday's, which was domain and range, because it'll be very helpful to understand interval. I go a bit slower on it. We also need to cover rate of change today, which is not interval notation. Okay, so let's go from there. So increasing, it's always when we look left to right. Increasing is just when the graph is going up. Okay, so increasing is going up, and decreasing is going down. Okay, so we're just going to say from what x value to what x value is it going up, and from what x value to what x value is it going down. Now, we don't care how far or how fast it's going up or going down, just the interval of where it's going up or down. Okay. Now, rate of change is different. Rate of change is essentially slope. So in a linear equation, it's just going to be its slope. But if it's exponential or nonlinear, okay, then we need an interval. Okay, from what x value to what x value are we going to judge this slope? Okay, so we'll take a look at that and go from there. So really quick, just to remind us, okay, interval notation is kind of like yard lines in football, right? And that is an awesome way to line up, isn't it? There we go, complete now. So let's say, we hike the ball, we toss it back, run around, throw it, okay? This player runs up and gets tackled on the 10-yard line right there. Okay, then later on in the game, we do a similar thing, but this time we throw it up here. Well, this guy catches it, and he also gets tackled on the 10-yard line. Then our quarterback, a third time, he just runs through and gets tackled right here. Okay, it doesn't matter on a football field that width, right? We don't care over here as opposed to over here. You don't score more points by getting a touchdown in one of the corners, okay? They don't have different zones that are worth more points. So those yard lines is how we determine how close they are to scoring or not, okay? That's like interval notation, okay? We could say here the play went from the 30-yard line to the 10-yard line, okay? That's the interval in which the play happened, where it started, where it ended, okay? That's the same concept for increasing and decreasing. So, increasing we're going to do as green. Decreasing we'll do as red, okay? So, if I'm looking at my graph on number 1, okay, I can see right here from this point, it's increasing as I go to the right? Because I said we always look left to right on graphs. Always, 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 always. So, what's my yard line? Well, it goes from the 30-yard line to the 15-yard line. Okay, so that interval would be from 30 to 15, from left to right. Now remember, with intervals, we always use the brackets. Okay, so when I write increasing here, but I can't use the yard lines, so I use the x values. Well, the x value right here would be -3. And the x value right here would be +8. So from -3 to +8, that's when my graph is going up. Do I care how fast it's going up? No, I don't. Just that it's going up. Okay. Then as I look for decreasing, we start right here, and it's decreasing till we hit that minimum. So it ends at -3, and it begins at -8. Okay, yard lines, that would be 5 to 30. But because we use x values, it's -8 to -3. Now, I do need to apologize. I didn't realize how dark the football fields were on last time's notes, so I apologize. You guys couldn't really see it very well. I think today's worksheet is a little bit better. Okay. So that's increasing and decreasing. So I'm going to go through increasing and decreasing first, then we're going to deal with rate of change. Okay. So that's how we're going to attack these. All right, let's take a look at the next one. Now, sometimes they may be doing increasing or decreasing more than once. So if I look at this one, I see I'm increasing, and then I'm increasing again, and I'm decreasing right here. So what are my intervals of increasing? Well, the x value is -4 till I get to 0. So from -4 till 0. But then it jumps to a second part, and it starts at 4 to 5. So when it jumps, I do that little u, that union, which means there's more to it, and I go from 4 to 5. Now decreasing, we start at 1, and we end at 3. So from 1 to 3, it's decreasing. Now once again, I don't care how far it was going up. I don't care that it went from -4 up to 0. I don't care it went from 0 down to -2 or -2 up to +2. I care about the x values, these interval pieces, and seeing where that happens, okay? All right, number 5, okay? So start here at this point. Now it's decreasing, decreasing, decreasing till we hit right there. But I'm only caring about the x values. So -6 till I get to -2. It's decreasing. Then it starts increasing. So from -2 it starts increasing until we hit +2. Then it stops increasing. Then we start decreasing again. Okay, so I make a little jump, and it's decreasing from 2 until we hit 3. So 2 to 3. Then I'm going to start increasing again. Now we've got that arrow, so it's just going to keep increasing. Okay, so we're hitting that end zone. Remember, we call that end zone infinity. So it starts again here at 3, so a little jump. Starts at 3, and it keeps going until it hits infinity, which we know means it never ends. Okay, and that's our increasing and decreasing. Okay, notice that in these ones that there's no gaps like here. Okay, I go decreasing to increasing to decreasing to increasing, and together, you know, -6 to -2, -2 to 2, 2 to 3, 3 to infinity. Okay, if I were to write the domain would be -6 to infinity. It would fill up all the domain because it's continuous in increasing and decreasing. All right? So now with the table, it's a little different. Okay? We still use the x values, okay, but we're going to have to think about it a little differently. So I look at my y values. 5 to 4, that's going down. 4 to 3, so I guess I should write that with a red, huh? 4 to 3 is going down. 3 to 0, still going down. 0 to 3, now it's going up. 3 to 4, it's going up. 4 to 6, it's going up. So at what point do I start going down? Well, we started at right there at 5, right? So I start, because our intervals use the x variable, I say from -4, and it's going down, 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 down until it hits -1. Okay, that's the interval from -4 to -1. It's going down. Then, once we hit -1, guess what? Now we're going up, 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 up. And we keep going up till we get to 2, which is the end. Okay, now it's going up. Okay, now you may think this is discrete, so shouldn't we be writing down all these numbers when it's going up? In this case, no, because we're talking about increasing and decreasing, not about each separate piece. So it's okay to write it this way. And remember, these stand in for x values. So -4 to -1, -4 to -1, furthest left to furthest right. -1 to 2, furthest left of increasing, furthest right of increasing. Okay? So those are going to be a little different, and that's okay. All right, number 9. Okay, so number 9, same idea. So 25 to 20, it's going down. 20 to 15, down to 10, down, 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 down. So this one just goes down the whole time. So guess what? Is it ever increasing? No. Okay, you could put that empty set right there to indicate that it never increases. Decreasing, well, it started decreasing at -1, and it ended, as far as we know, at 6. So -1 to 6. All right, number 11. Okay, so 25 to 20, it's down. Then 20 to 22, it went up. 22 to 26 to 28 to 30 to 31. So it's increasing. At -2, it starts increasing till it gets to 1. So -2 to +1. And decreasing from -1 to -2. Okay? And there's all we have to go with on that. Okay? Increasing to decreasing. But remember, it's the x values. I think that tends to be some of the toughest information to deal with, is that we're only dealing with the x values. Okay, now we want to deal with rate of change. All right? So I'm going to clear the ink so that we can deal with rate of change. Now, rate of change is slope, so it's rise over run. Okay, it's the vertical movement over the horizontal movement, and we always go left to right. Okay, so what I need is an interval to tell me where to do it. So we'll just pick one out. We'll say from -4 to +5. So I go on my x-axis and I go -4 and +5. Then I'm going to find where my graph crosses those points. So -4, it crosses at the x-axis. Maybe I should have picked a better point. Let's actually do to 3, because that'll work better for our example. Sorry if you already wrote 5. We'll switch that to 3. Okay, so it goes up, and my point is right there to right there. So my question now is, what's this slope? That's what rate of change is asking. Now, is it the same way? We know that in reality it goes down and then comes back up. But with rate of change, we're only concerned with like the direct, closest, easiest way to get from one point to the other. So to do that rise over run, I'm going to see, okay, how far up do I need to go? So 1, 2, 3, 4, 5. Okay, so I go 5 up. Up is positive. Then how far to the right do I go? 1, 2, 3, 4, 5, 6, 7. Right, and I really should have drawn my line up there. So 7 to the right, which is positive. So my slope would be the vertical over the horizontal. So rate of change is 5 over 7. So the rate of change of this function on the interval -4 to 3 is 5 over 7. Now with these nonlinear problems, okay, I could get a different slope. Let's say instead of -4 over 3, I decided to do -8 to +8. That's the interval of rate of change I wanted to do. So if I did that, I would start up here at -8 and end here at +8. Well, I'd go up 1 and to the right 16. So my rate of change would be 1 over 16. Okay? So it depends on that interval. Now, the only time it doesn't is if you have a straight up linear equation. Because if you do, that's like the steps, okay? It's always going to have the same rate of change. So we're just going to practice with one rate of change. All right? So let's take a look at number 3. So our interval is going to be from, we'll say -2 to 5. And I'm just picking these. There's no reason why I'm doing certain ones. So at -2 to 5, I find where my line hits. My line hits here. My line hits up there. Now I'm going to do this rise and the run. So 1, 2, 3, 4. Goes up 4 to the right. 1, 2, 3, 4, 5, 6, 7. So my rate of change, 4 over 7. Okay, and that's all there is to it, guys. So number 5, let's do an interval from, we'll say, -6 to 0. So -6 right there, 0 right there. Find where my graph is at those x values. So now I go down 1, 2, 3, 4, 5. It's down, so it's negative. To the right, 1, 2, 3, 4, 5, 6. So my rate of change, -5 over 6. Okay? So hopefully we get that concept down. All right, now with the tables, okay, it's basically the same type of thing. The only difference is this y is our vertical, so that goes on top. The x is our horizontal, so it goes on the bottom, okay? So let's say we've got a rate of change from -4 to 1. So I find my points here, -4 to 1. So -4 to 1, how far did we go? Well, negative, so what I can do is I can go 1 minus -4. Okay, if I take the bottom number and subtract the top number, that's usually the easiest way to do it. So minus a negative is plus, and I get 5. So it changed by 5. You could also count 1, 2, 3, 4, 5, because they count by ones. Now for this, same idea. If I take that 4 and I subtract the 5, that's going to give me the vertical. 4 minus 5 is -1. So this made a change of -1. That one's a little bit tougher to see. Okay? So the vertical, -1, over the horizontal 5, and my rate of change is -5, 1. Okay, now you should maybe notice this, but that 1 and that -4, same numbers in my intervals because they're the x values. So I really don't even need to circle these. I could just use my interval. Let me show you what I mean. So let's say we wanted the rate of change from 2 to 6. 2 is right here, 6 is right here. So my horizontal change is just 2 minus 6, which is -4. Okay, using these two, I can do it that way. Okay, actually not -4, huh? I needed to do it backwards because 1 was in the back here and it ended up being in the front. Great. Tried to show you a shortcut, screwed it all up. So I take the back one and subtract the first one, which would be a +4. Big difference. Okay, then I find the y values, so 10 and -10, and I set it up in the same situation. So 6 and 10 belong together, so I put them in the same area, minus 2 and 10 belong together, and I get -20. So -20 goes on top because the y values go on top. Now, do I know what -20 divided by 4 is? Yeah, it's -5. Can I say my rate of change is -5? I could. I could even say -5 over 1 or -20 over 4. Either one of those work. All right, number 11. We're almost done, but we've got a little extra to look at here due to being able to do this with equations, where the other stuff we can't really do it with equations. Okay, so rate of change here. Let's go from, how about -2 to +1. Okay, so if I go 1 minus -2, 1 minus a negative is plus, so that would be 3. So my horizontal change is 3. Then at -2, I have a y value of 20. And at +1, a y value of 31. So if I go 31 minus 20, we get 11, and I get 11 over 3. And I want to keep it like that. You could, I guess, if you really wanted to, go 3 2/3, or even put it as a decimal, but I'd prefer that with rate of change, we try to leave it more like a fraction. Now, there may be some cases when we want to find it as a decimal, and that's all right too. But for right now, we don't have to worry about that. We can just leave it as a fraction. All right, now let's see how we deal with just equations. Okay? So, with equations, it can be a little tricky. Okay, we're going to have to use our evaluating skills also. So the first thing we need to do, and so you should probably write this down on the page somewhere. Ask the guest teacher to pause it so you can write this down. But we've got an interval again, from 0 to 10. Those are the x values. So I can right off the bat go 10 minus 0 and find that the horizontal change is going to be 10. Okay, but what about the vertical change? To find that, I need to know what the outputs are, given these inputs. So I evaluate. Okay, so for f of 0, I get 2 times 0 plus 5. 2 times 0 is 0, plus 5 is 5. So f of 0 equals 5. So for the 0, the y value, the output, is 5. Now I do it for the 10. So I go f of 10 equals 2 times 10 plus 5. 2 times 10 is 20, plus 5 is 25. And I get 25, right? F of 10 equals 25. So I get 25 minus 5, which is 20. So my top number is 20. Now, 20 divided by 10, I can reduce to 2. And maybe you spotted this, but this, you should have noticed, is a linear function. That multiplication and then the addition. Okay, that tells me it is linear, and the slope is always with the x. The slope is the rate of change when it's linear. So in that case, I could have just looked at my slope and got the answer that way. But I wanted to show you how to do it the long way also. Because when we go to g of x, notice this one is exponential. We're multiplying, and we've got the exponent for repeated multiplication. Okay, you may want to say, oh, well, my rate of change is I'm timesing by 2. And we said rate of change is that linear aspect of it. So I'm going to have to do some work here. Okay, so I know I take the 4, subtract the 1 to get my horizontal, right? So 4 minus 1 is 3. So I know my bottom number of my rate of change is 3. Now I'm going to have to plug in my numbers. So 1, so I go g of 1 equals 3 times 2 to the first power. 2 to the first is 2. 3 times 2 is 6. Following order of operations, remember we always do powers first. So I have 6 here. Okay. Then we do g of 4. So 3 times 2 to the fourth. Well, 2 to the fourth, that's like 2 times 2 times 2 times 2. You can either use a calculator and type it in, or realize that's 4, then 8, then 16. So I get 3 times 16. Then if you need to, use the calculator again, or you realize 3 times 10 is 30, 3 times 6 is 18, 30 and 18 give us 48. So g of 4 equals 48. So I get 48 minus 6. Okay, so 48 minus 6 is 42. So my rate of change over the interval from 1 to 4 of my g of x function is 42 over 3. Which just so happens to be 14, actually. And remember we said this geometric pattern is multiplying by 2. Definitely not the same as 14. Okay. Now, it doesn't matter what kind of function you have. Okay, if it's linear, you can use a shortcut. If you don't know what it is, you're just going to have to do it. Okay, this one is a quadratic. I know that because it's x squared. Okay, notice it also has 2 x's, so I'm going to have to plug in my x values twice. But I start off 2 minus negative 2. That's like plus, so I get 4. So at the bottom of my rate of change, I'm going to have a 4. Okay, then I plug in my negative 2, so h of negative 2 equals negative 2 squared plus 2 times negative 2 minus 1. Now, if you're going to go negative 2 squared in the calculator, make sure you put parentheses around it. If you don't, it won't come out right, because negative times a negative is a positive. So I'd get positive 4 plus 2 times negative 2, negative 4 minus 1. 4 plus a negative 4 is 0. 0 minus 1 is negative 1. So h of negative 2 equals negative 1. So for my vertical change, I've got minus a negative 1 equals something. Now I do the positive 2. So h of 2 equals 2 squared plus 2 times 2 minus 1. 2 squared is 4. 2 times 2 is 4. Minus 1. 4 and 4 are 8. Minus 1 is 7. So h of 2 equals 7. So I go 7 minus a negative 1. That gives me a plus. 7 plus 1 is 8. And I get 8 over 4 for my rate of change. Which, can I reduce that to 2? Yes. Is that always going to happen? No. That's just coincidental. Does that 2 match up with that 2? No, it doesn't. Okay? Not the same thing. Alright guys, so there we go with that one. Now on your homework you have a little bit more to do because we just went over rate of change, okay? So make sure you do all those rate of change problems as well as the increasing and decreasing on all the graphs and tables, okay? Only one more day of new notes, and then on Friday we'll take a quiz and you'll be able to practice this stuff some more, okay? All right, so get that homework done if you have time, and everybody finishes. Have your guest teacher show you the homework video.